In this video, we will be comparing systems of exponential equations. We will be looking at when the cost of a car and the amount of money in a savings account are equal. Reading the problem, one fine day, Clash bought a new car for $20,000. He also put $3,000 in a savings account. He expects the value of the car to decrease by about 15% each year. So this amount is going down by 15% each year. But he expects the value of his savings account to increase by 8% each year. We want to complete the table and graph to show the value of each for the next 12 years. So we're going to have t represent time in this situation. V sub c is going to be the value of car represented in dollars, and V sub s is going to be the value of savings represented in dollars. So we're given our two equations here that go back to what we know about exponential equations. So in terms of the value of the car, 20,000 is our initial amount. We're going to subtract our rate as a decimal, so our percent as a decimal, from 1 because it's decreasing, and raise it to our exponent of t. Same idea with the value of the savings account, except for our starting amount was 3,000, and our amount is increasing by a rate of 0.08 raised to the t. So in order to fill out our table, we're going to go to our calculator and type these equations into our y equals screen. So first off, we'll turn our calculators on and go to the y equals. Once we're on y equals, we can type in our two equations. So in y1, I'm going to type in the value of the car. In y2, I'm going to type in the value of the savings account. So in y1, I'm going to type in 20,000, parenthesis 1 minus 0.15 raised to the x. Remember, in the calculator, we have to always raise it to the x. We can't change our variable. For y2, I'm going to type in my second equation, 3,000, parenthesis 1 plus 0.08, close our parentheses, raised to the x. So now we have our two equations. In order to fill out our table, we can push the second button, and then graph. So this brings us to our table of values. Now we can fill in each table. So remember, y1 is the value of our car, y2 is the value of our savings. So we can fill this out. So when x is equal to 0, or our time is equal to 0, we have 20,000. Continuing down, 17,000, 14,450, 12,283, 10,440, $8,874.10, 7,543. So if we continue to scroll till we can get to 12, so we have 6,411.5, 5,449.8, 4,632.3, 3,937.5, 3,346.9, and our last value, 2,844.8. So that gives us our values of the car over those 12 years. So now to fill in the value for our savings account. So same idea, we're going to scroll up to when x is equal to 0 and start there. So we start with $3,000. Then it's going to increase to 3,240, 3,499.2, 3,779.1, 4,081.5, 4,408, 4,760.6, and then scrolling down to get the remainder of our values. So we have 5,141.5, 5,552.8, 5,997, 6,476, $6,994.8, $6,994.9, and $7,554.5. So now we have our table of values. We want to know if there's a solution to this system. So in order to find that, we want to graph these values. So I'm going to keep the corresponding colors. So for the car, I'm going to graph it in in pink. So at 0, we're up at 20,000. 1, 17,000, and so on. So I'm going to take the time to graph each of these values. You'll notice that some of these numbers are not exact, so we're going to have to estimate. So for 3, I have 12,283. 4, $10,440. 5, 8,874. 6, 7,500. 7, 6,400. 8, 4,449. 9, 4,632. 10, 3,937. 11, 3,346. And 12, 2,800. So our graph is going to look like that. So we have an exponential function that is decreasing. So we can go ahead and connect those points. And that gives us our exponential function for the car. We're going to do the same thing with the value of the savings account. So starting at 0, we have 3,000. Increasing at 1 to 3,240. 2, 3,400. 3,700. 4,081. 4,400. 4,700. 5,100. 5,500. 5,900, 6,400, 6,900, and 7,500. So as you can tell, it's a little bit off just because of the scale, but it would look something like that. In this case, it looks almost linear because of our scale, but we know that it's an exponential function because it's raised to the x. So we want to figure out where these two are equal. So when we look at our graph, we know that it's going to be somewhere around this area, okay, where those 2 points are together. So there's a couple of ways that we could do this. So one, we want to know, is there a solution to this system? And yes, there is, because we know that when two graphs intersect, that's the solution. So we want to figure out exactly what that solution is. So we're going to go back to our calculator. From our graph, so we'll click on the graph button, we can compare our graph that we drew to the graph on the screen. So it shows on the calculator that these graphs are also going to intersect. So on here, we want to figure out their intersection. So we can push the trace button, second trace, and it will give us a few options. So we can scroll down to intersect. This will tell us exactly where they intersect. So we choose our first curve and our second curve. So this little cursor says that that curve, y1, is our first curve. Now it's going to jump down and our cursor is on our second curve. So we push enter. Now we can guess, so we can scroll as close to the intersection as we can get. So I'm going to say just about right there. I'm going to push enter, and it's going to tell me exactly what my intersection point is. So my intersection point is when x equals 7.9 and y equals 5,519.49. So our solution in this case, x is 7.9, y is $5,519, and we'll round up to 49 cents. So the next question asks us, well, what does this really mean? So in words, we want to know what is 7.9 and what is $5,519. So the way that we could word this is, after 7.9 years, the value of the car, so the value of the car and the value of the savings account are equal. After 7.9 years, the car is worth $5,519.49, and the savings account has $5,519.49.